Hello class, this is lesson 1-2, simplifying fractions, where we will be talking about reducing fractions and simplifying them to lowest terms. This is the Learning Needed channel. My request to students, remember your reason to pass the GED test. Whatever your reason is, it is your reason and it is a great reason. Keep that reason close to your heart as you go through studying and passing these GED tests to get your GED certificate. Second is to not give up. This is not meant to be an easy task that you knock out in the weekend. It does comprise of 4 tests to get the GED certificate, and through hard work and perseverance, as well as using sources online such as this channel and books and anything else, you will get that GED certificate as long as you push through the hard times, the studying, and getting what you need to pass that test. Finally, please like and subscribe to this video and my channel. I can only produce these videos through your continued support, and I do plan to have videos for all 4 subjects on my channel and have more resources to help you out. If you are interested in one-on-one tutoring in any subject in the GED math to help you learn that last piece that you're just not understanding, or to have a live walkthrough of a lesson or subject or even a problem that you are having trouble with, please check out my website in the video description below. Study material that I often suggest to my students is the Kaplan GED test prep book. It comes by years. The latest year as of this video is 2024 to 2025, but most years share the same material format and mostly even the same questions, so don't feel pressure to get the latest year. Any copy that you get, even at a used bookstore, will work just fine. And note that for the GED math test, the only calculator that you are allowed to take with you in person is the model TI-30XS. If you are interested in purchasing a copy of the Kaplan GED book or a calculator for the GED math test, I have links to purchase those in the video description below. Alright, let's get started. Simplifying fractions. A common step that you will need to take in the GED math test when dealing with fractions is reducing them to lowest terms. And what this means is simplifying the fractions, or simplifying the numbers to make them easier to work with. The way that we do that is that we divide both the numerator and the denominator by the same number. And the number that we divide both of them ideally would be the greatest common factor. The greatest common factor is the largest number that divides both numbers, in this case the numerator and the denominator, without leaving a remainder. I will show you examples of how to find the greatest common factor in the next slides. But a note before that is that simplifying fractions does not change the value of the fraction. All you're doing is really just changing how it looks. One of my favorite real-life examples to use when talking about fractions is pizza. So if you look at 2 pizzas, each cut up to a different amount of slices, then the size of the slices change depending on how many pieces it was cut into. So if I were to tell you I ate 6 slices of a pizza, that sounds like a lot, and in fact it is most of the pizza. There would only be 2 slices left if the pizza was cut up into 8 slices. But if I were to tell somebody that hasn't seen the pizza, I've only eaten 3 of those slices, they might think, oh, that's actually not a lot. But that might be because they're thinking that the pizza is cut up into a lot of slices. But they would be surprised to find that by eating only 3 slices, I've already eaten most of the pizza. And that's what simplifying fractions is doing. It is representing the same amount of pizza, but just with different numbers, where the pizza with the least amount of slices is easier to work with than the pizza with more slices. So let's look at an example of simplifying a fraction. It is asking us to reduce 30 over 45 to lowest terms. And in order to find the lowest term fraction, you have to find the greatest common factor. And we find the greatest common factor by getting the factors of both the numerator and the denominator. And the factors of a number are the numbers that multiply together to get that value. So if I look at the factors of 30, for example, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And the way that you read these are that 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, and 5 times 6 is 30. And those are the factors. Similarly, for 45, the factors are 1, 3, 5, 9, 15, and 45. So it'd be 1 times 45, 3 times 15, and 5 times 9. So those are the factors of each of the numbers separately. The greatest common factor is which of these factors is the greatest that both of them share. So they all share 1. However, we don't really look at 1 because every number has a factor of 1 in itself. So we start with the immediate next number. So for 30, we start with 2, but I see that there is no factor of 2 for 45, so I don't look at that one. Both 30 and 45 have a factor of 3, so that's good. That could be a potential greatest common factor. But they also share 5 as well, which means that 3 is no longer the greatest common factor. Though it is a factor of both, it's not the greatest. And I move forward. So 6 is not in 45, so I can't use that. 9 is not in 30, so I can't use that. 10 is not in 45, but 15 is in both of them. That means that 5 is no longer the greatest common factor. And then 45 and 30, which are the last numbers, they are not shared by both numbers. So the greatest common factor for both of these is 15. So now that we found the greatest common factor, the next step is to divide both the numerator and the denominator by both of these numbers. So I divide 30 by 15 and 45 by 15, and that results in a fraction of 2 over 3. And this is the fraction 30 over 45 reduced to the lowest terms. Let's look at an example problem. Here we are asked to reduce 21 over 35 to lowest terms, and our goal is to find the greatest common factor. So we look at the factors of 21. And what are factors? Again, are numbers that when multiplied together give you that number. So 1 times 21 is 21, and every number always has 1 in itself as the factors, so those are always ones that you can count on to be there. But what other numbers can I multiply together to get 21? There is no number that I can multiply 2 by and get 21, but I can multiply 3 by a number to get 21, and that number is 7. So 3 times 7 gives me 21. So far I have the factors 1, 3, 7, and 21. And there are no other numbers that when multiplied together give me 21. So these are the factors of 21. Looking again at 35. 35 has factors of 1 and 35, and that is 35. What other numbers can I multiply together to give me 35? And I cannot multiply 2 by a number, I cannot multiply 3 by a number to get 35, nor can I do with 4, but I can multiply 5 times 7, and that gives me 35. And if I go through the rest of the numbers between 1 and 35, there are no other numbers that I can multiply together to get 35. So the multiples here are 1, 5, 7, and 35. And so those are the multiples of both 21 and 35. So looking at these 4 factors of each, we see that the greatest common factor is 7 for both of them. And now that we have the greatest common factor, we divide both the numerator and the denominator by this factor of 7, and the answer becomes 3 over 5, where 3 over 5 is the lowest term version of 21 over 35. Example number 2. Reduce 8 over 21 to lowest terms. Again, greatest common factor. Looking for the factors of 8, we have 1 and 8. We also have 2. I know that I can multiply 2 by a number to get 8, and that number is 4. And that is it. Those are all the numbers that are factors of 8, 1, 2, 4, and 8. Looking at the same thing with 21, we have 1 times 21 as factors. And we actually just did this one in the previous problem, so we know that the only other number factors that we can use for 21 are 3 and 7. So we have 1, 3, 7, and 21. So those are the multiples of 8 and 21. Now we look for the one that matches for both of them. And we see that actually here, the greatest common factor for both of them is 1. But when the greatest common factor of both numbers is 1, that means that there really is no greatest common factor, because when you divide 8 and 21 by 1, you get the same numbers. So that doesn't help us. It doesn't help us reduce this fraction to lowest terms. So what this really means is that there is no greatest common factor, such that 8 over 21 is its simplest form. You can't reduce it any further, so 8 over 21 is a lowest term fraction. And the last example problem, reduce 24 over 30 to lowest terms. Sometimes finding greatest common factors might not be the best way to do it because the numbers are really large and going through all the factors might take up a lot of time. So there is another way to reduce this fraction lowest terms, but it won't be in one step. I ask myself, what number can I divide both of those numbers by and get answers that have no remainders? And I know that I can divide both of these numbers by 2 and get an answer that does not have remainders. And 24 divided by 2 is 12, and 30 divided by 2 is 15. And I ask myself, is this the lowest term number? And the way to check that is if there is no other number that I can divide both of these by and still get an answer with no remainders is how I know it's lowest terms. But I look at these fractions and I think, wait a minute, I can actually divide both of these by 3 and I get answers with no remainders. 12 divided by 3 is 4 and 15 divided by 3 is 5. So I actually simplified the fraction twice. And when I simplified it the second time, it became 4 over 5. And I asked myself the same question. Can I divide both 4 and 5 by a number and get an answer that has no remainders? And in this case, I cannot. I cannot divide a number by 4 and by 5 and get an answer with no remainders. So 4 over 5 is the lowest term fraction. But something that you may have thought of while I was asking what number can I divide both 24 and 30 by, you may not have actually thought of 2. You may have actually noticed and stated, wait, I can actually divide both 24 and 30 by 3 and I get answered with no remainders. 24 divided by 3 is 8 and 30 divided by 3 is 10. And those look different than when I divided by 2. But again, the goal of this is to get the fraction in lowest terms. So I asked the same question. Can I divide 8 and 10 by a number and get an answer with no remainder? And the answer is yes. If I divide both 8 and 10 by 2, I get 4 over 5. And that, again, is the lowest term answer. So this is different than the greatest common factor approach only because you are working on it as you see it. So you are not doing any pre-work of finding the greatest common factor first and then dividing by that. You are instead using the fraction itself and asking, what can I keep dividing it by until I can no longer divide anymore? And so this is a different approach to these problems, and that works as well. But essentially, what you're doing is the work in multiple steps instead of in one step when you find the greatest common factor. But either way works, and with more practice, this will become more ingrained in your workflow. So that was today's lesson, where we learned how to simplify fractions by finding the greatest common factor, and in the last example problem, how to do it by dividing directly onto the fraction itself until you can no longer get an answer with no remainders. Thank you guys so much for watching, and I'll see you guys in the next lesson.